Hey, James, good to see you again.
Likewise. How are you doing?
Uh, I'm doing pretty well. I want to welcome everyone. This is an exciting new adventure for us. Live reactions to data engineering Reddit. This is going to be fun. What we're going to be doing today is reacting to some of the most commented on posts in the data engineering Reddit community over the last year or so, and try to discuss some of the more relevant topics and see where we get to. And obviously, comments are encouraged. If you want to post a comment in the chat or a question, I think we'd love to open up the discussion to everyone in the community.
Yeah, I'm
Um,
really curious to see what people think about our takes on a lot of this. Just because I'm sure everyone has a different perspective on all of these topics.
oh yeah, I'm definitely looking forward to it, and I'm sure some of these will get a little contentious. I can
Oh
already just
yeah,
tell from the posts that they will. Um, and kick us off, let's do a quick round of introductions. I'm Igor. I'm the co-founder and CTO here at Big Eye. We're a data observability platform. We try to help people find out about their data problems before they impact the business in any way. So if you are struggling with broken dashboards on a daily basis, reach out. And with me, I have James Greenhill. He is a data wrangler at Post. James,
Chief Data Wrangler
Chief
at
Data
Post.
Wrangler. There you go. What does Chief Data Wrangler mean, James?
Basically, I'm making sure that we get the data into the places we need to store it. It's stored in the right shape, and we can use that shape in some way that makes us, well, provides value for our customers and maybe makes us a little bit of money too.
Well, that's. I feel like that's data engineering in a nutshell.
Yeah, pretty much. Pretty much.
Take data, put it into a different shape, and put it somewhere that provides value. Loving it. Um, awesome. So I think we can just jump straight into it and see where we get to. And as I mentioned before, feel free to ask any questions, comments in the chat, and we'll get through them too. All right, first post, and I think this is one of my favorite ones because I feel like this topic comes up in discussion every couple of months. How are we all preparing for the recession? And this is the recession. Do we see a huge impact on data engineering jobs? I think my favorite part about this is the post is from a year ago, and everyone's still talking about the impeding recession and the doom on the horizon. So, James, how are you feeling about the current economic climate?
I'm feeling good generally. I think we've kind of stuck the soft landing for the most part. We'll see how things go. I think it's still, no one really knows. But if you do want an answer to this question, you just need to look back at like what happened during COVID, where I think panic hit the market and we didn't really know what was going to go on. Generally, the same cycle. Like it's just a cyclical thing, and you just look to see what history tells you. And the way I think about it is like buy, sell, hold. Like if you're a company at different stages, and there's no one answer for this, right? Like it's so dependent on like what the product for the company is, like where do you sit? How does the company define data engineering? But for me, the way I was thinking about this is basically like at a larger company, you're probably not going to be impacted. You might, but the thing that you will definitely impact you is what you're working on. Immediately, and this probably is across the board, but you're going to be looking at how to cut costs, how to do more with less. It's going to be a lot less of like the greenfield stuff and a lot of like we need to tighten the spend on all of these things. How do we do it? If your organization does tend towards the sell, I think that you're going to find other organizations looking to buy. Like typically, especially for venture-backed companies, like you see an explosion of startups and downturns a lot of times. And you're going to see a lot of companies doing data-intensive products. They're going to be hiring data engineers. And so we've seen this before, people moving from larger companies to smaller startups. That cycle just is on repeat all the time. If you're a mid-sized company, probably again hold. I would think that again, you'd probably be seeing like, priorities change. I don't think it'll impact your job terribly much, but it's interesting just to look at the past for me. And also, I want to give a shout out. Hey, buddy, it's been a while. We should catch up.
Yeah, I hear you. I think the second comment on that post was, look, as long as there's data, we'll need data engineers. We never run out of the need for plumbers or electricians. And yeah, it just boils down to what are they being used for? And
Yeah.
what are you doing with those data engineers? Is it something that's immediately value add? Is it cost cutting measures? Is it, oh no, our Snowflake bill is 7 figures and we can't afford that anymore?
Mm-hmm. Yeah, it's like, is the data also getting forked over to the Datadog, and do we need to like figure out how to reduce cardinality for that?
Great.
It really depends. I do think the universal truth though is that priorities will change, and you're going to find yourself working on maybe a different product than you were working on before. It might be a little bit less like greenfield and optimistic, and it might just be more like, hey, we just need to get things under control and be like really diligent and disciplined versus building like really cool stuff. Both are cool, but different. They're just subtly different.
Yeah. And looks like we need to share our posts, and I need to mute myself before I. Yeah. I'll just start dropping the posts in just to chat.
There you go. I like
or Adriana can too as we go through them.
Yeah, that'd be nice. I don't even have a chat box.
Yeah.
I just have to talk with people.
I now see myself in two places. I see myself on LinkedIn, and I see myself on the stream. But I totally hear you for that. It does really just depend on what gets worked on. But I don't see data engineering as a industry disappearing as a.
No, absolutely not. Yeah. No, and the thing is, one of the big theses that I have is that as the tooling for building data intensive products, so products that are built off of like aggregates, analytics, increases, you're going to see this become more and more in what I call the critical path of a company, like what is actually driving the product. And the more data engineering ends up in that critical path, the less likely it is that you're going to see demand for data engineering decrease. Yep. Now, if you're just doing a lot of times companies will hire like data engineers just for gigs, like just to come in and be like, hey, give me some dashboarding and some solid reporting that I can use for my board. And then, they come in, spend a couple months, maybe a couple quarters doing that. And they're like, okay, I'm done. This is it. Like it's set and forget. Hopefully they're using something like Big Eye so they can be like, okay, if this ever pages, give me a page and I'll come look at it. But a lot of it is relatively turnkey. But I do think as companies become more and more data intensive and they're building these dashboards that are facing customers, it becomes more critical, and it's part of the critical path. Like it's infrastructure at that point. Like it's what's driving revenue, and you have to invest in it.
Right. As the way that we think, the way that I describe our target market is, if your business is making money with the data, then you care enough about the data to monitor it.
Well, you've effectively moved it from the cost center to the revenue center in that case, which changes completely how you're looking at that product, at the data product. Yeah. If you're entirely a cost center, like the organization is going to look at you differently. Like it's a cost minimization problem versus if you're in the revenue center, it's like a revenue maximization problem. Right. Just a different optimization that companies think about when looking at those two types.
Yeah. And I think that's actually an interesting segue into the next post around leadership without a data background. So the question there is wondering if anyone has any advice or experience working as a data engineer when leadership/architects do not have a data background.
I love this question. Yeah. Like, I think it's such a good question. Just because I the thing is, before we move on, do you have anything you want to add to the last question? I feel like anything at all?
No, I think the last question. I think the consensus there is the job's going to remain. It might look a little bit different, but data still matters to people, and as an industry, it'll still be around.
Exactly. Yeah. Now, this next one, I just really love, just because this is most people. Most of the time, when you enter if you're early stage or even later stage, your customer is going to be not a data person. Mm-hmm. And I think the biggest thing that you can do, the best thing you can do for yourself and for the organization, is just be skeptical of everything that talk with your customer all the time. Like really try to understand what they need and what they want, but be skeptical of some of the details, especially around I want it to be real time. As soon as you hear real time, it's like, oh, but wait, there's a huge trade-off we're making here. Do you need it real time? Is there any business value that will be generated because it is real time? Because the operational side of a real-time pipeline versus a batch pipeline, even if it's an hourly batch pipeline, is a completely different monster. And so and this is an evergreen thing that everyone who doesn't know just thinks, oh, real time is just like easy, right? You know, it's just something you do. Like it's the same thing. And it's like, no, it's actually very different. So, and that applies to a lot of things, you know, basically just try to get to the kernel of like what they need, what the business needs. And if you can service that quickly, especially like the other thing is iteration on a batch pipeline is way faster, way easier. And you can backfill easier too, which means that if you do make a mistake, it's easier to correct the mistake. You know, just try to be pragmatic about it. And, you know, the other thing, it's not exactly how what I would describe to like managing up, but just make everything idempotent if you can too. Just like a universal, like teach them what idempotence is and why it's important. But that's what I would mainly say, because most people don't understand the cost trade-offs of a lot of what they're requesting. And really, you just got to try to boil it down to what the business needs and what they need.
The whole story about, oh, leadership wants real-time data resonates with me so much. James and I did overlap at Uber for a period of time. And I'm sure, James, you remember the infamous dashboard. I forget what it was called at this point, but it was every 15 minutes you could see how many trips are being taken.
Yes. Yeah. It was the executive dashboard. I forgot what it is, but
it was the executive dashboard.
It was independent of everything else.
There was a team. There was just a whole team of engineers supporting that. And we needed it in real time, and we needed to update all the time. And the biggest question I've always had is, what decisions are we making in real time off of this information? And the answer is not really, but it's a cool number to see.
Yeah. I mean, like the only time there are some instances where real time makes sense, where you need to act fast, like, you know, outlier detection, anomaly detection type things. You know, I know Big Eye has a lot of this stuff, but like if you need to know, like, let's say you're a city manager and you need to know like something you did, maybe Flipper, if you remember Flipper, like broke like all of like calls or hails. You know, that's something you need to know fast. Like someone needs to get paged, or you need to get on top of it. That type of thing would be really good. But yeah, for the most part, for data engineering, you're dealing in batch, and that's usually where you should be.
I love that, because the number of times that I've gone to people and said, "Don't worry about real time. You probably don't need it," is quite a bit. But I agree with you. Sometimes there is a real case for it. Financial services is a big thing. Credit card transactions.
Yeah, absolutely.
Fraud. Look, you have to process the payment within a few seconds. It has to get done. Like I'm not going to stand there at the cash register for 2 minutes while I wait.
Wait for the next batch job. It's like crypto.
But beyond that, I generally agree. Like, start with batch. There's always going to be batch problems to solve. I think the other interesting thing that you mentioned is making sure you're connecting it back to the business. Like abstract away from the technology.
Yes.
I think when leadership comes in and says, this is a cool technology, generative AI. Everyone loves generative AI. And if they come to you and say, we need generative AI, the question should not be, all right, how are we going to do generative AI? It should be, great, what are we solving for? What's the product going to use? How are the users going to see this? And that should then inform the requirements for that role, job and that project, rather than starting with the technology and then kind of moving backwards. It's always the business value should inform the use case.
I think we have a community question too. Yeah. We have Buddy asks, from the article, has very strong software engineering backgrounds. Is this just a timing thing? Does data engineering actually become software engineering? I do think that what we've seen, especially with like all of the data, modern data stack, like all the data products that are being created right now, you know, back when we were doing this like full time, it was the Wild West. Like everyone was doing stuff in production all the time. It was kind of nuts. And we've seen a lot of engineering best practices migrate into the data engineering stack and world and mentality. And I think that it hasn't completely taken over. I still think, you know, as with engineering, but like you still see a lot of fly by the seat of your pants and just get things done. But I think that you do see the lines blurring quite a lot. Yeah. But it's still, I think, specializations. Like I don't think that they will blend together entirely. I don't think a off-the-shelf software engineer is going to do the same things as an off-the-shelf data engineer. It's the same thing as like an SRE. Like, you know, they have different things that they're looking at and different priorities and things that they want to get done in the organization. But I think that you're going to see the same practice, like the same discipline in the job. Because a lot of times I don't know about you, but basically I was a data scientist and I started doing data engineering because no one else was doing it. So that meant that I had no idea what I was doing. And I was definitely not coming from like a software engineering background. And it was very much a like, oh, the software runs on my laptop. Don't unplug my laptop, please. And you see it like that doesn't happen quite as much anymore, but it's still going to be its own field for sure.
It's going to be its own field. I talk a lot about how data engineering is borrowing quite a bit from software engineering to your point, from these practices and process perspective, where I always kind of go back to the inflection point for software, which is AWS, the cloud. I can deploy new software very quickly. I can build new things. I can prototype things. And this isn't I have a new project. I buy a new physical server and I stick it in my closet in the rack. Those days are gone, and that made software really accessible. And data engineering's going through a similar thing. And so true. A lot of those practices that software engineers had to learn the hard way of how do I do like continuous deployment to the cloud? How do I like know that my server is actually up and running? I can't just open the closet and see that it's on.
The wiggle mouse.
And so a lot of these things are now being adapted to the data space. And so I don't think it becomes the same thing, but what will happen is I think data engineering is going to learn a lot from what happened with software engineering over the last decade or so, take what makes sense, and then adapt it to make it their own. Because like continuous deployment doesn't exist in data engineering. There's not like I'm going to add new features every single day and just release a new pipeline every single day. That doesn't happen.
And then like revert.
Pipeline's there. Data's going to flow, and sometimes the data changes, sometimes the requirements change, but it's not on a daily basis. It's on a monthly, yearly basis. And then the practices that you need to know about are, great, how do I know that it's running on time? How do I make sure that it's not running out of memory? How do I do resource optimization around it? Things like that.
I think something that you touched on is really interesting, which is the barriers to entry for data have come way down, much like software, but for data in particular, with Snowflake and BigQuery and every other, cloud platform out there that allows you to query large amounts of data, which used to be only like if you could afford to set up a Hadoop cluster or run EMR and know how to run EMR. And because of that, I think you've seen a lot of peripheral companies products spin up that support people getting into this to make sure that they're doing the right things. Something that I really like that happens in the SRE world is you see a lot of things that are processed as product. If you look at like incident.io, like they're basically coming in very hot, like with very opinionated a process as a product that you pay for. And you see a lot of that in the data world now, which I think is great. I think it basically is showing people, for a very nominal fee, you're paying for something that helps you run your processes in a way that is productive. And that's I know you guys are doing something very similar to that, but it makes a lot of sense, I think.
Yeah. And this is, PagerDuty is a great example of this. On-call processes have existed for decades, and PagerDuty wrapped it and said, this is the best way to do it. And we're going to create products that are very opinionated about how you should organize your teams and services and rotations and escalation.
Run incidents and all that. Exactly.
Awesome. Let's move on to the next one. I'm excited about this third one. I don't know about you, but I have plenty of data engineering horror stories to share. I'd like to hear the one that gives you shivers.
One.
And I want to also invite the audience, if you have your own data engineering horror story, would love to hear it. But James, I'm sure something comes to mind.
Yeah, well, like the one that always I look back at because I just remember the feeling that I had. You've used Hive.
Yeah.
And, Hive is basically a way of running SQL queries on Hadoop. It would basically transpile a SQL query into a MapReduce job, or later like a TES, or it had a pluggable backend engine. But at the time, it was just MapReduce. I wrote a query at GrooveShark and the thing is, Hive had two different types of tables. You had a normal Hive table, which it managed, like basically it was very native to Hive. It was all in HDFS at the time. And then it had an external table. And you didn't really know what type of table it was unless you described it. And so I was playing with the table that I thought was an external table. Mm-hmm. And the thing is, with an external table, it doesn't actually manage any of the storage. It basically is a way of like, it's kind of like how most data warehouses work. You basically describe the data that is in the HDFS path, and it will query it for you. If you drop the table, you're just dropping the metadata that you're using to describe what is in HDFS. Hey, Vishon. Yeah, well, one day I worked at Grooveshark with Vishon. So, so one day I'm just working on Guts, which was the Grooveshark user tracking system, and I drop the table thinking it was an external table. And I remember thinking, like, this is taking way too long. And turns out it was taking way too long. It's one of those times where it's like the meme where, it's like you do the thing and the nightmare is like, oh, 2 billion rows affected. And you're like, what? Like, it's not supposed to affect any rows. So yeah, I remember that vividly. And I also remember learning how to spin up another EMR cluster to rebuild that table really quickly, because we basically built a lot of our products off of that. So that was painful.
I'm completely not surprised that it involves dropping something, deleting something.
Yeah.
I mean, the post itself talks about, oh no, so we deleted a bunch of our largest customer and all of their records, and now all the metrics change because we hard deleted it. No soft delete, no backups, no nothing, just rip it all out.
Yeah, it's easier than you think. It's make sure backups are not for hardware failures. I'll just say that.
Yeah, mine's a little less. Mine's actually not about deleting; it's overwriting. Ooh. When I was working on the experimentation platform team at Uber, we processed a bunch of logs around. You log into the app and you see a green button or a blue button, right? Which one do you see? Well, that's based on on whatever experiment's running. And we would log that, and we would say, James sees a green button, Egor sees a blue button. So we're talking about I don't remember what it was, about 1.5 terabytes of logs a day, I think.
Yeah, easily.
And so crunch all the numbers and clean it up, dedupe them, and normalize them, drop them into a cleaned up table that we can then summarize. And that whole pipeline took, I think, 4 hours to run end to end. So we took about 1.5 hours to dedupe and clean up the logs, and then about another 2 hours to do the roll-ups to the user level. And that all worked fine, but that was a Spark job. And the Spark job was the same in production as it was locally on my machine, and that's totally fine because that makes it easy. I can test it out locally and I plug it out in my little dev environment, and I write a little side table, and then I'm like, great, the results look good. Now let me push it to production and then run it in production. The problem is pointing the output to a different table was a manual step. And at one point I forgot to update the manual step, and it pointed to production, and I'm like, oh, I need to test I need to backfill one experiment worth of data over the last, I think it was few weeks. And so I pull it and I filter everything out other than that one experiment of hundreds, and I write it in, and I'm like, something looks wrong here. This table only has 10 gigs a day now, and this doesn't seem correct. So had to re-backfill a month's worth of data, and then rerun all the aggregates for a month's worth. Yeah, that was not fun. I very quickly learned to separate out, okay, we cannot, no writing to production ever out of a dev machine.
It's a hard lesson. I still write to production. I probably should not, but it is one of those things where it's out of my cold dead hands. Yep. But you do have to be careful. You have to be you double, triple check it.
At Big Eye here, we have our SRE team wrote a little MySQL wrapper. We use MySQL under the hood, and if you are in production, there's a big, the prompt just has a big danger.
It makes sense.
Mark in the front. And
it's so easy. It's so easy to just forget what environment you're on, and it's oh yeah, I'm just going to drop this table locally. Oops, and that will happen. The thing is, and my advice to anyone who's in data engineering, it will happen. Just be defensive. have backups, test your backups, like fork the table, storage is cheap, like test on a test table locally, don't have the namespaces line up, like do things that'll minimize the risk of this happening. But it does happen. It doesn't mean that you're a terrible data engineer, just learn from it.
Also, something that I try to follow is always connect to a read-only replica. If you have a read-only replica, just use the read-only replica. Better safe than sorry. Don't just.
So true. That's such an easy thing you can do too. Like if you just have a read-only user that you distribute, it's like, hey, go crazy. Like you save yourself a lot of potential oopses.
Yeah, definitely. Well, if anyone in the audience has any horror stories they want to share, we'd love to hear about those. I feel like everyone has something. And then it's always production related. There's always like, I logged into production and did something bad.
Always.
Yeah. I feel like as engineers and as data engineers and software engineers, you just kind of get away with it so many times that you get sloppy because you're like, oh, I got away with it 30 times before. I'll get away with it one more, and then you don't.
Yep. Yeah, and also what Vishon just said, we've had these issues somewhat recently. But yeah, basically transactions, like leaving transactions completely open, that will definitely take you down. You'll basically just get a bunch of locks and you'll never clear those locks. Or if you just have transactions that are taking too long in your master database, and you have like a thundering herd of them, and all of a sudden it's like, why are we getting 500s? But yeah, there's one other one that happens a lot. If you manage the infrastructure at all, which is pretty classic, and it feels terrible when it happens, running out of space on the root disk. For whatever reason, maybe you have logs there and you shouldn't have logs there. And all of a sudden, like something happens, you dump a bunch of logs to your root disk, and all of a sudden SSH isn't working, and you can't log onto the box, and you're like, what do I do? That's stressful.
I used to manage a Vertica cluster. Well, I used to manage Vertica clusters a lot for a while.
One of seven?
One of seven, yes. But one time back at before Uber, I was at One Kings Lane. We had our Vertica cluster, but it was Vertica needs the nodes to. It's distributed, and this was all like physical hardware in a rack, and the nodes need to talk to each other, and ideally on a different subnet so that they're not, because it's just noisy. There's a lot of noise, a lot of data transfer going. They were connected to the same production subnet as our production web servers. And I was doing a major I needed to load like 10 terabytes of data, and okay, I have all my zip files and they're all in an S3, and I'm just going to start shoving them into Vertica, and the nodes will distribute the data and everything's fine. And then it just took down the whole link. The whole network link, I couldn't SSH. We had someone in this data center had to go and push the button and be like, no, kill this. Right.
Yeah. Decongest it.
Yeah.
That's wild. That's not something I've had happen before, but that's pretty bad. I mean, beyond Amazon having issues on US East 1 where they lose their control button. But yeah, that's intense.
This is the joys of cloud warehouses that I find. Snowflake is phenomenal. I just kind of throw stuff at it, and
that's true.
It figures it out.
Yeah.
I mean, BigQuery is very much the same way. Databricks is very much the same way. You just kind of throw stuff at it, and something will work, and it'll happen behind the scenes.
They've sorted out their infrastructure. They've done a really great job. All of these cloud providers are second to none in terms of sorting out, delivering just a really high quality product, making it look easy when it really is not easy. It's a really hard product to build.
Yeah. Awesome. Well, so. Next post, I personally enjoy posts like this. We're on post 4 now. So I'm currently a data warehouse engineer making $140K a year. What skills should I master next to increase my salary to $200K and eventually to $300K? What are some positions with higher salaries that I could transition to? Any advice would be greatly appreciated.
AI. Just do AI. No, I'm joking.
Generative AI.
Just do AI. Yeah,
your whole resume, just one big word.
Burn it. Just to spin it so it sounds like you've been working on LLMs for the last 10 years.
Yeah. I think the reason I find posts like this interesting is because they always remind me of Blind. I don't know how many people here have been on Blind before. It is an app. I think it's still around.
Yeah, I think so.
The blind app is anonymous like questions and feedback for like within companies. So if you're at Uber, you were part of the Uber blind, but you also be part of the larger like Silicon Valley blind community. And on blind, everyone loved to talk about how much money they make, and there was always like in every post there was like, what is your total compensation? Total comp,
Every
like
time.
everywhere.
Yeah.
And I just found that so tacky and so just
I mean, I'm sure most people made up like the numbers, but some of the numbers you look and you're like, there's no way. Either that or I'm doing this all wrong. Like this is way too high. Like I'm 2 years out of school and I'm making 2 million total comp. It's like what?
Yeah, but I think to this guy's question, he then goes on to list out a few skills that they've already mastered: SQL Server, SSIS, looks like it's Microsoft Stack, Tableau, Excel, VBA. Interested in data engineering, AI, cloud, but have a strong programming background. Well, that's a good start. There's a lot I want to learn, but which skills would get me to 200 to 300K, and what would that require? The way that I look at a lot of the comments here, actually, I really resonate with me in terms of they call him out for call the original poster out for just listing technical skills. And this kind of goes back to our conversation a few minutes ago, where it's about the business requirements. What does the business use the data for? And having the soft skills, business intuition, product intuition to, prove your value to the business is going to get you a much longer way than hard skills.
Yeah. The other thing I look at here is like, if you can move away from like, I'm just making assumptions, but if some of your day or a lot of your day is spent doing ad hoc reporting, move away from that and try to make yourself a multiplier. Build tooling that'll enable these things to be done. Like automate yourself out of your job as much as you can. Mm-hmm. If you can do that reliably and on a recurring basis, you will be paid more money because you'll be more effective. Not only, and I'm not talking about like just build these tools for yourself, build them in a way that other people on your team can use them. Mm-hmm. And you'll find yourself growing up the ladder quite quickly, because that's really what differentiates, a middling engineer to like a breakout engineer, mm-hmm. is whether or not the engineer can, one, to have the soft skills like you were saying and advocate for making the right decisions and things that are like maybe not the most clear decisions, mm-hmm. or popular. And the other one is just like have a proven track record of building tools that enable other engineers to be more productive. And if you can be that multiplier, like you're good. Like you'll command a higher salary for sure, because you're making that business impact. You're making the business more effective. You're making things faster and more repeatable. Yeah. And then you also onboarding. Like when you do hire more people, like you'll have the tooling and the docs to onboard those people so they're effective more quickly. So like just articulate that up, like do it and articulate it. Like don't hype yourself too much, but be sure that it's seen and visible, and you will definitely find yourself growing in the organization.
Yeah. Yeah. I would second everything that you said. The way that I look at it is making sure you're aligning yourself also with business, that like, what's the business goals and the business strategy? Because the most important projects you can work on is the ones, and the most that you're going to get buy-in for are the ones that the business cares about. Yeah. And if you are constantly working on important projects, people are going to notice you and people are going to say, hey, you're paying attention, you're working on stuff that matters. Yep. And then that's going to go a long way.
That's actually bringing it back to what you were saying earlier. If you can find a way, this is really meta if you can do it, but if you can find a way to transition whatever you're working on from being in the cost center to the revenue center, that's mm-hmm. another huge way to win. Yep. And if you have equity, like that's, you have a lot of control over the equity as well. Like it's, if rising tide rises all boats, and if you have a boat in the tide, you're going to be doing pretty good.
I also think part of it is knowing how to justify your work and the worth of your work.
Yeah.
So going back to cost center versus revenue center, you could make data into a revenue center, but unless you have the numbers to back it up and you say, hey, this is my team has 5 people and we are generating $10 million of revenue a year. So mm-hmm. therefore this is a worthwhile project to invest in. That's one thing. But I feel like a lot of times you have more of an intuitive sense for why things are important and why your work's important, yep. rather than a quantifiable
Yep.
sense for it.
Absolutely.
And sometimes it's hard. Sometimes the quantifiable part is just really, really, really hard. But, order of magnitude helps.
Yeah.
Like, is this a $1,000 problem? Is this a $10,000 problem? $1 million problem? Where on the spectrum is it?
Yeah. You make what you measure.
Yeah.
And if you can measure, even if it is imperfect, if you can at least, like you said, order of magnitude measure it and see like either the opportunity or the impact you're making, like you'll be better off for sure. You'll see yourself climbing up the comp ladder.
I do think, if I can take it back to the technical skills, I know that we talked a lot about the soft skills. I do think there's something to be said for having niche technical skills.
Oh yeah.
I remember I read an article a few years ago about COBOL developers, because COBOL is still in use by a lot of banking,
mainframes. Yeah,
mainframes,
core banking. Yeah, spend some time doing some integrations with this.
Right, and people just don't want to learn COBOL anymore. And the people who know COBOL are going to get paid a lot of money because they know COBOL.
Yeah, and
that's one way to swing it. But then the way that I would look at it is, now you're running COBOL all day, and do you really want to be doing that?
Yeah, I agree. It's like if you can find pleasure or find your passion in that, do it. Go for it. But if it's like pulling teeth, you can find that increased salary somewhere where you have passion. You just have to be a little creative about it.
Right.
If you can find an area where you're super passionate and there's a scarcity of supply, just like roll into it. But it's an interesting question too, just in general. Like, if you had to say like what would be the next emerging, or like not even emerging, but just tech that if you had to like do IC work all day and specialize in one thing, what would it be? What would you bet on, rather? Not like, maybe not what your passion is, but what would you bet on is going to be something that demand is going to be high or scarcity is going to be high?
That's a good question.
Yeah.
I think there's a lot of fundamental, from a data perspective, I think I'd still be in data. I do data.
Oh yeah, for sure.
I enjoy data. I think that's the real truth there.
Yeah.
I think what's happening right now is there's a lot of lessons that are almost getting relearned in data, where data modeling is a great example of this. The number of times I've seen posts that says, "Is data modeling dead?"
No.
Is it still a skill that we need? It's yes, it's always a skill that you need.
It's just so underappreciated.
Yeah, compute and storage got cheap, and that's why people kind of forgot about it, because they're like, just dump raw everything somewhere and then we'll
unstructured,
process
into the lake.
And then the lake turns into a swamp.
Yeah.
And so for me, really the interesting part here is the skills that are sort of like forgotten because of how easy compute and storage got. So data modeling, cost optimization, performance, things like that just people don't think about nowadays.
Yeah. I think what I would probably bet on is a lot of like, we're getting to this point. I don't think we're on the brink of like HTAP or hybrid transactional analytical processing database engines, but I do think that a lot of the newer database engines out there are really interesting and kind of pushing the limits of how traditionally, if we were to build a dashboard, let's say we have a food delivery service and we wanted to build a dashboard for all of the restaurants so they could see like what orders are going out, like what's their daily volume and what are their most popular dishes going out. Traditionally, you could invest in a big old like, cluster or Druid or something like that. Or what a lot of companies would do is they develop a data pipeline and like ETL effectively, like do a big batch job, create the output, ETL that into like Postgres or MySQL and serve it from MySQL, right? As like a caching serving layer. And, you do lose a little bit of like, I do kind of see people wanting, for a customer, it's harder to articulate why real time is not as important for a customer. They just kind of want it. And so if you can provide that in your product and it's compelling, like, I think that's really interesting. So I think that we'll see people moving away from that. And I know Snowflake is working on this. ClickHouse, I'm very biased. I love ClickHouse. I spend most of my day toiling in the mines of ClickHouse. But like DuckDB is kind of interesting too. But basically you're seeing this new wave of cloud and just open source databases that are providing OLAP so fast that, and with these really interesting materialized views that don't do all like big snapshots, but do incremental aggregations and updates, that you can actually build really nice dashboards and products that are real time, but they're kind of micro batch. And so you still are able to do backfills, and you're still able to change your logic and apply that logic in a way that's not like super bespoke one-off. I would say invest in that. Like that would be my, if you were interested in data and you wanted to know a field that I think is really interesting and hasn't yet like developed fully and is still kind of on that precipice, I think that is going to be where a lot of really interesting stuff is going to be developed soon.
That's true. The HTAP thing is, I've been seeing that a lot more in the last 9 months, probably 9 to 12 months.
Yeah, it's interesting. I don't know when we're going to get there. Just because, like, just so the audience knows too, like OLAP, OLTP, HTAP. OLAP is online analytical processing. Imagine just like you're writing big queries. You have a few of these. They're reading over a bunch of data and aggregating it. OLTP is more like Postgres or MySQL. It's online transactional processing. You're usually doing point queries where it's like, get Igor's user. I need him. He's trying to log in. And HTAP, like those are two completely separate workloads for a database. Like they look completely different. Usually the patterns and everything look different. And the hard thing is you usually want to have your OLAP, your analytics database, synced with your HTAP. And that introduces all sorts of problems. But basically, HTAP is this new idea of like, why not just have one database that kind of does both? So you can use it as your source of truth, your OLTP, but also you can hit it with analytics queries and it'll just work. You don't have to worry about synchronizing the two. And I think that's going to be really interesting in the future too. Like you can kind of do this already with some databases using change data capture and materialization, all this stuff. But I do think at some point we're just going to end up with like just turnkey, like it works for extra storage and compute. You know, you're gonna have to pay more for it, but like it will just like it'll be fat free. It'll be so easy to set up.
We got a question from LinkedIn about, in a similar vein, what advice would you give a CS student who is exploring the field? I'm guessing data engineering, the field. What skills would you recommend focusing on?
I think something that is bringing the barrier down to entry. There's two things you can basically start playing around with data, like set up pipelines, like find a play data set out there. There's a ton on S3 that are available for free that you can just get and do all sorts of slicing and dicing, and just practice setting up pipelines and analyzing it using a database. Like that's something, to be an effective data engineer, you really have to understand your customer too. I really believe that. And like, if you can kind of put that data scientist hat on and understand how like people are going to be hitting the database, so you can understand like what schema you need to build for certain query patterns, you'll be ahead of everyone else already. So like you can look at things like DuckDB, which is like you can basically download this binary and run it locally, load it with a ton of data. It's really fast and requires almost no infra experience and gets you going. Like really, like you can use Apache Arrow, and like there's all sorts of these really neat concepts that you can learn about just by putting this on your laptop and putting data through it. Same thing like ClickHouse has a ClickHouse Local. They're trying to do something similar to DuckDB. But yeah, just look at stuff like that. You know, just try to get your hands dirty. Like go out, make a toy product, grab a bunch of data, and just try to hack on it.
And then the way that I like to describe data engineering skills is in buckets. So the way that as a CS student, the best analogy is a loop is a loop and a function is a function, and different programming languages have slightly different ways of slightly different syntax or convention for it, or exactly how it works. And like, sure, there's classes versus like functional languages versus object oriented, but the logic flow is the same. And once you understand the logic flow, you can write a program in any language. You just need to know the syntax and the concepts.
Exactly.
And so the way that I think about data engineering is there's a logic flow. You're going to have data sources. You're going to have like understand what does the data look like. It has a structure, and it typically like is queryable either through an API or through a SQL, which is another API. Or and then that data needs to get moved somewhere. It needs to transform. It needs to then be presented to usually in a dashboard. So data sources, transformation, data movement, BI tools. You got or like reporting tools. You got your buckets.
Yep.
Learn a tool in each bucket. Once you understand the concepts, it's just mapping the tool concepts to the higher order bits.
Yeah, and just, you know, if you find one of those buckets that you really want to specialize in, like try to make it faster. Try to make put more data into it until it breaks. How do you fix it? Yeah, just keep pushing the boundaries. And like what Buddy was saying, basically, if you use that, get your hands dirty and have like a pet project, document, put a blog post out. God, they always perform well. Like if you have a side project where you're just trying to do some analytics on like Doppler radar data off of AWS, you can get that data from the Nextred Doppler system. You can write a blog post, and then when you go to apply for a job, you can point to that blog post and say, "Hey, check out what I did. It's pretty cool." And like that adds a lot of credibility, not only experience for you, but credibility for yourself as well.
A lot of at Big Eye, our very first data set that we played around with ourselves to test out the product was actually public COVID data, because we got started like around circa 2020, 2021, when California started releasing public data on a daily basis. We're like, great, let's build a pipeline, load it. How does this integrate with our product? What issues do we detect with it? Like you just play around with it, and that's the best way to learn about the technologies.
Yeah, it's. I think that's a really great way. Like, basically a great way to come up with a demo and dog food your own product. But like, I'm sure you learn something along the way while dog fooding. Like that's the entire idea of dog fooding, is learning. And yeah, it's just applying that at a personal level.
And then, Buddy, I'll go back to the buckets, and then Namsu will get to you right after that. The buckets that I consider is the data is coming from somewhere. So how do you read data? So understand how to query APIs, how to like connect file systems, pull files.
Kafka, Red Panda, like all of the different like Confluent, like just read up about streaming data pipelines. Oh, actually, yeah, keep going. Sorry, I've got a suggestion.
So data goes somewhere. Data comes from somewhere. Learn how to read the data. Learn how to then transform it in movement. So you need an orchestrator tool. So something like Airflow and ETL. Either that's going to be in Python or WYSIWYG if you have a WYSIWYG ETL tool, or maybe it's SQL transformations with dbt. And then you're going to load that data somewhere, and then you're going to read that data for a report or something user-facing, which means learn some SQL to debug a report, to build a report, to do whatever you need to do. So the buckets are really pull the data from somewhere, do something with it, then present it. Yeah. And those are the buckets. And from a skills perspective, that would require like API, SQL, Python, more SQL, a lot of SQL. Learn SQL. If you don't know SQL, just learn SQL right away.
Yeah, one piece of advice for anyone in data, like know SQL well. Like you got to know SQL. The other thing I'd add one bucket. So you have sourcing the data, storing the data, accessing the data, and then I guess presenting the data.
Yeah.
Was that the last one? But the storage is also really important. Like how do you make sure to store the data in a way that makes sense? That's kind of like the schema. Like what tools do you use? Do you put on S3? Do you need to have it somewhere hotter? Like, that's like something to look into and get familiar with.
Yeah. And then another comment, Namsu. Namsu is a data science student and wants to be an expert data engineer like us. I am honored to be called an expert
I know, right?
in anything.
I'm not worthy.
I am purely wondering what professional goals you have. That's a big question.
It's a big question.
I know. I'm like, wow, this is like I feel like
really philosophical.
My ultimate goal and why I build software, why I do data things is I believe that technology can make people's lives easier and better.
Yeah.
There's a lot of things that we as data professionals, as engineering professionals, as even just humans surviving do that we don't like doing. And we can automate a lot of this. It's things that we have to do, but we don't like it. And so on building tools to automate the things that we shouldn't be spending our mental energy on, so we can spend our mental energy on things that are more productive for us, for the business, for us as a society, for you personally. That's really my passion. And so my professional goal is really just keep chasing that. What is the next thing that we can automate? What is the next thing that we can, next piece of toil that we can eliminate for our users of Big Eye? And honestly, I do a lot of scripting for myself just so that I don't have to repeat myself.
Yeah. Automate yourself out of the job, even personally.
Yeah.
No, I think that makes sense. I think for me, what drives me and has always driven me is I really love building applications. It's very similar to what you're saying, but building applications that people love to use. You know, a lot of times it could be either a vitamin or a pain pill. Like, you know, basically it's like for post hoc, for instance, you know, it's something that everyone who's trying to build a product brushes up against in terms of a challenge, which is like, are people using my product? Where are they having bad experiences? Where are they dropping off on the funnel of like the happy path of converting into maybe like a persistent user or a paying user? And helping them understand and giving them the tools that they need to build that product easier and have better clarity. Because, you know, as someone who's building a business, the last thing, like you don't want them to be questioning themselves and like just have doubt, like, oh, I don't know, like where I should be investing my time, like, or my engineering team's time, like where are the problems happening? And for me, that's what I've been doing for almost my entire career, is like helping people understand how people are using the product, and maybe building products based off that. But I really like that. For me is very gratifying. Just seeing people use the product to build their own products is like neat. And it could be anything, you know, at Groove Shark, watching people use like the radio that we built, like it was like, oh, that's so cool. Or using it while you were building it was even cooler. You know, or Uber, like you go out and you use the service and you're like, yeah, you know, I played my little part in building this and I really enjoy it. I do enjoy data engineering, but it has to be to an end. Like I wouldn't sit down and do it for no reason at all. Not quite that academic. I do enjoy the concepts, but to get me really engaged, it has to be with a product that people want to use. Mm-hmm. And that is like that's like what drives me. That's my, if at the end of my career, I look back and I see that I spent my time building products that people want to use, and you know, if I'm lucky enough that they pay to use, like I'd be very gratified. I'd be very happy with it.
And I think this kind of goes back to your earlier point, James, products might also mean internal tools. Might mean
absolutely. Yeah.
You have 100 engineers that are using a script to automate 10 minutes of their life a day. You are providing your product. It doesn't have to be a web UI. It doesn't have to be anything. It could be just a script that helps you automate some tedious processes.
Exactly. No, I totally, that's exactly right. And that's, you know, the cool thing about an internal tool is you kind of get a captive audience too, but you can talk with your users really easily. You know, you can go and sit down over lunch and be like, how do you like the tool, and get that feedback and continuously improve it. And that's fun to me.
Yeah. We got about 8 minutes left, so I'm going to wrap it up with, I'm going to skip the 5th post and I'll just go straight to the 6th one, because I think this will be a good way to end it. Is data at every company still an absolute mess? This is great. So, the post talks about how this person switched from mechanical engineering to data engineering. At first, I was pretty oblivious to a lot of stuff, but as I've learned, I look around in horror. There's so much duplicate information, bad source data, free-for-all solo project DBs. Everything is a mess, and I can't help but think that most companies are like this. They are.
That's so true. No matter the size, no matter the stage, you know, it may not be true. I have not worked at Google. Maybe they have like, you know, the shining building on a hill, but every company I've worked at, it's always a mess. It's always just a dumpster. It's like your advertisement, which I absolutely love, the dumpster fire. Like you look at it and you're like, oh, wow, this is bad. And the thing is, it's not just data engineering. Like it definitely, like, it's software engineering in general is like this. You know, tech debt, bit rot, whatever you want to call it. Over time, things just kind of like you accumulate a bunch of detritus on your code base. And the real thing is it manifests itself in data. Like the output, like the code, you may go and refactor the code and make it gorgeous, but guess what? The data's still there. And so all of those scars manifest themselves in the data. And so like you end up with some real good stuff. You can see all of the skeletons. So yeah, it's, you know, honestly, one of the best places for data, I think, was actually Uber. I think the internal tools, you know, between Trust, Databook, like there were so many internal tools that tried to get ahead of this, and were very proactive about keeping things under control. We still had, you know, an explosion. I don't know how many tables we had. And I think it was actually, even from like an engineering perspective, we had more prod DBs than we had. Like we had a pretty solid data warehouse story, you know, basically one warehouse, one pool of resources, one set of tools to admin it, really great ways of getting data in with HeatPipe. Like it was pretty coherent, but that's not true everywhere. A lot of the places it is like, you know, it's on a floppy under the bed.
Also, I agree. Uber had a the data team at Uber was excellent, but
Yeah.
to your point, there were, I think 2017, Uber had more microservices than engineers.
Yeah.
And what does that mean for data? It means there's just a lot of data sources with a little bit of data that all needs to tie together. And so that's more pipelines to manage. That's more business logic to understand.
Yeah, it was this like Cambrian explosion of data, especially because the tooling was so good at getting the data in, that collecting side with HeatPipe. People from microservices were like, oh, I'll just fire away all my logs and like we'll deal with it later. And so you had this huge corpus of data that you never touched. And it was hard to understand. Like after the fact, you don't know what is important or is not. Like the data, like before you delete it, you're like, well, there might be like that one report a year that's run on this that like is required for like, you know, an S1 or what, not an S1, but like a quarterly report. Like we don't know. So that's where Databook came in. It was quite nice. But yeah, it definitely it's hard to clean up. And so it's always a mess.
Yeah. And then I think the top comment is my favorite. Welcome to data engineering. that I think that just summarizes all of that. And also the second one, job security.
That's also true.
But I think it goes back to my point. I'm like, this isn't the job security that I want. I don't want my job security to be, digging through.
No, you want, that goes back to like, you want to build the tools that will get you out of that trap, because eventually you'll end up basically like just trying to keep the lights on with the data that's available. If you can get ahead of it, you can build newer things. But otherwise, like you and your organization will always be prioritizing fixes and things that you have to do to keep the lights on versus doing really interesting stuff with new tech that may open up new doors, like versus just keeping the lights on for the things you've already explored.
Yeah. And I think Buddy's point is also interesting. I will not ignore this because this is a good point. Technology is going to make our lives better, but the more we create, the more work and busy we seem to be. I don't think there is ever an end to achieving the why. But to this point, I think the work changes. There's more work, but it's different.
Yeah.
And you kind of move. It's almost like up the Maslow's hierarchy of needs from a like,
yeah,
what do I want to be working on perspective.
Mm-hmm. You're just trying to stay alive, and then it's like, okay, we're alive.
I mean, at my first job, I literally was putting servers in a server rack and then connecting them and then deploying applications to it. And from that, I went to managing Vertica, which is physically installing RPMs on servers and connecting them and making sure the networking is correct and running, like managing the warehouse. And that was busy work. And I didn't like doing that. And we scripted that away. And now Snowflake comes along, and Snowflake has different busy work, which is, okay, what does your warehouse layout look like? How do you do your data modeling? So on and so forth. Just it's different. There's always going to be work to do, but we are moving up the pyramid to more, intellectually captivating work is the way that I like to think about it.
Yeah, definitely. The SaaSes that are coming out to handle all the lower level stuff are making things a lot easier. And it's exactly the same thing with the engineering with AWS and EC2 and Kubernetes and all that. Like the barrier to entry for all this stuff is decreasing. You don't have to understand the entire stack to get these things out. You just have to know like the business, like the bit that you can contribute to. And usually you can find something to build off of to get whatever you're trying to get done. Yeah. One last thing I wanted to talk about before we wrap up, Adriana posted a link to Amazon, which is a book. If you want a book on data-intensive applications, which is a fantastic book, it's by Martin Kleppman. Read that. It will talk about everything that you could possibly want to know about. It's maybe a little bit more engineering and data engineering. Like it blurs the lines a little bit, but it'll make you conversational when you're talking with people about serializations or Kafka or storage, like log structure merge trees. It'll make you conversational, at least know what's going on. It won't make you an expert, but it will definitely you'll know more than 90% of the people out there. Yeah.
Well, we're running up on time. We got about a minute left, so thank you everyone for chiming in. This has been great. James, thank you for participating. It's always a pleasure to chat, and it feels like our casual hallway conversation.
It was fun. Yeah, it was fun. I really enjoyed it.
It's fun. Everyone who is listening in, feel free to subscribe, share the stream. and follow our page on LinkedIn. Adriana posted it in the chat. It's Big Eye. And we are also going to be launching a Slack community soon for data engineering conversations like this. So feel a message me or Adriana in the chat if you want to find out more about that. And we're hoping to do more events like this and have more conversations like this. So,
and real quick before we go, shameless plug for Big Eye, because if you're entering the data engineering space and you have not been burned by bad data or missing data, especially like subtly missing data where you don't notice for a while, it's only a matter of time. It's not if, but when this happens. And Big Eye can help you detect it before it's a real problem. There's nothing more embarrassing than having someone, especially like an executive or someone who's like really important, a VIP, open up a dashboard and go, I can't trust this. There's a Dutch proverb that I really like. Trust arrives on foot, but leaves on horseback. And it's like, you do not like cherish the trust that your customers give you. Buy Big Eye, or just use data observability. It will save you. It's only a matter of like when.
Yeah, it's true. It's true. That's our goal. Make sure that you can keep the trust of your team, trust in the data, and use it for good things.
Yeah, because if they don't trust it, why are you building it?
Exactly. Awesome. Thanks. Thanks again, James. It was a pleasure. Thank you, everyone, for dialing in, and we will see you next time.
Ciao.